Imagine transforming a territory that's 60% desert into a prosperous and productive region. In Israel, this became a reality through one of the most audacious engineering projects of the 20th century. In a land where rain is a privilege for only 3 to 4 months a year, and only in the northern region, ensuring water for the entire territory was more than a challenge. It was a matter of national survival. The solution found was as ambitious as it was necessary: to build a system capable of transporting water for hundreds of kilometers, overcoming mountains, crossing valleys, and conquering the desert itself. With that, the National Water Carrier was born, the largest infrastructure project ever undertaken in Israel. A project that not only reshaped the country's landscape, but also redefined the limits of what was possible in hydraulic engineering. Today, thanks to this revolutionary project, there isn't a single place in Israel without access to water, even in the most remote regions of the Negev Desert. In this video, we will discover how Israel managed to change the destiny of its nation forever and transform a desert territory into a prosperous and productive region. This is Construction Time. I'm Luciano Guimarães, and in this video, you will learn about the National Water Carrier, Israel's largest water project. The National Water Carrier, or Israel's national water transporter, stretches out like a vital artery from the Sea of Galilee in the north of the country to Mitzpe Ramon in the far south, through an intricate network of aqueducts, tunnels, and reservoirs in a truly impressive way. The challenge begins at the very starting point, the Sea of Galilee, located 209 meters below sea level, with a depth equivalent to 70 stories. From this point, the water needs to be raised to a height of 44 meters above sea level, an engineering feat that allows it to flow through more than 130 kilometers of infrastructure. The magnitude of the project is revealed in its impressive numbers. The main pipelines, with diameters of up to 3.6 meters, are true underground highways of water. The tunnels that cross mountains stretch for kilometers, while gigantic reservoirs store millions of cubic meters of water, ensuring a continuous supply even during periods of scarcity. To ensure maximum efficiency, the system operates through 3 main lines, each with its specific function. The first line transports high-quality drinking water drawn from the depths of the Sea of Galilee. The second line manages more brackish water, while the third, a later innovation, is dedicated exclusively to recycled water for agriculture, supplying an impressive 140 million cubic meters of water annually for irrigation in the Negev Desert. But how did the idea for this incredible water project in Israel come about? The story of Israel's water carrier is a tale of determination and ingenuity. It was born out of the most basic need: to ensure the survival of a young nation in one of the driest regions on the planet. In the 1950s, Israel faced a double challenge: explosive population growth and the ambition to make the Negev Desert habitable. The path to the final solution was marked by trials and adaptations. The first project, developed by the American engineer James Hayes, proposed an apparently simple solution: to draw water from the Jordan River, taking advantage of the natural slope of the land. However, the complex geopolitical realities of the region forced a complete redesign of the project. American specialist John Cotton found the definitive solution by adapting the project to Israel's territorial reality. His proposal, although technically more challenging and financially more costly, proved to be politically viable. To use the Sea of Galilee as the main source of water, this decision not only circumvented international tensions, but also laid the foundations for one of the most efficient water systems in the world. The project has evolved significantly over the decades. What began as the goal of providing 80% of its water for agricultural irrigation now presents the opposite reality. 80% of the water is allocated for domestic and industrial use. reflecting the transformation of Israel from a predominantly agrarian society into a modern technological powerhouse. That's where the idea for this Israeli water mega project came from, but how was it built? This water project was built from 1956 to 1964. It revolutionized Israel's water system through an extraordinary journey that starts at the Sea of Galilee and ends in the Negev desert. To understand this engineering feat, let's follow the path that the water takes throughout this entire system. It all starts in the depths of the Sea of Galilee, where specially designed underground pipes draw water, 209 meters below sea level. From this point, the water is carried to the Sapir pumping station, the beating heart of the system. This station is equipped with 3 gigantic pumps of 30,000 horsepower each, enough power to fill an Olympic swimming pool in less than 3 minutes. From the Sapir station, the water begins its ascent through special concrete pipes designed to withstand pressures of up to 70 atmospheres, a pressure equivalent to what is found at 700 meters depth in the ocean. These pipes lift the water for 2.2 kilometers to an open channel, from where it begins its journey toward the south of the country. One of the most ingenious aspects of the project are the 2 siphons, which allow the water to cross deep valleys using the principle of communicating vessels, the same principle that makes water seek its own level. These impressive structures have internal diameters of 3.10 and 3.60 meters and reach depths of up to 150 meters. That height is equivalent to a 50-story building. After the siphons, the water passes through 3 main tunnels excavated in the mountains. The Shimron Tunnel, which is 1.5 kilometers long, the majestic Homage A, which is 6.5 kilometers long, and the Homage B tunnel, which is 350 meters long. Each tunnel was meticulously built to ensure that not a single drop of water is lost along the way. Before reaching its final destination, the water flows through the Eskol Reservoir, where it undergoes a sophisticated purification process in 3 stages. First, a physical-chemical treatment with aluminum sulfate removes impurities. Next comes a unique innovation, a biological treatment system that uses different species of fish as natural sanitizers. Marine carp and silverfish work together to control algae and microorganisms, while herbivorous carp keep aquatic vegetation under control. Finally, the water is treated with chlorine dioxide, enriched with fluoride, and exposed to ultraviolet radiation. From the Eskol Reservoir, the purified water is distributed through a network of pipes that reaches every corner of Israel, from coastal cities to agricultural communities in the desert. To ensure that this complex system works perfectly, main pipes with a diameter of 2.5 meters allow for regular inspections with special vehicles. Meanwhile, a computerized system monitors the water quality 24 hours a day, performing detailed chemical analyses 3 times a day. This incredible construction is able to transport water for more than 130 kilometers, overcoming gravity and rough terrain, to turn the desert into fertile land and ensure drinking water for millions of people. This way, Israel was able to fully meet its demand for drinking water throughout its entire region. To truly understand the magnitude of the Israeli project, it's important to compare it with other giants of global water engineering. In Brazil, the transposition of the São Francisco River emerges as a project of continental scale, moving 127 cubic meters of water per second through 477 kilometers of canals. With an investment of over 12 billion reais, this Brazilian project faces challenges similar to the Israeli one, especially in moving water through rugged terrain. However, it is inefficiency that the Israeli project stands out. While the Brazilian project records losses of about 24% of the water during transport, The Israeli system keeps its losses below 3%. Even more impressive is China's South-North Water Transfer Project, a truly titanic undertaking that redirects 44 annually. The North Project has an estimated cost of $62 billion. This is the largest water transfer project ever built on the planet. And if you want to know more about this water project in China, we also have a video talking about it here on the channel. Interestingly, although much larger in scale, the Chinese project incorporated several technical solutions pioneered in Israel, especially in the current monitoring treatment systems. Improving water, showing the lasting legacy of Israeli innovation. This water transfer project transformed Israel in surprising ways. In agriculture, it enabled the development of drip irrigation techniques, turning the country into a world leader in precision agriculture. Today, Israel produces 95% of its own food, exporting more than $2.5 billion in agricultural products annually. In demographic terms, the project made possible the creation of more than 50 new settlements in the Negev Desert, transforming a region once considered unshakable because of its desert into a hub of agricultural and technological innovation. The city of Be'er Sheva, for example, grew from 20,000 inhabitants in 1950 to more than 200,000 inhabitants today, becoming a center for research in water technologies. The environmental impact was also significant. The system allowed for the recovery of coastal aquifers that were being contaminated by saltwater, as well as enabling the reforestation of large areas of the desert. Israel is among the few countries that finished the 20th century with more trees than it began with. On the technological side, the challenges of the project drove the development of innovations that are now exported globally. The technologies for desalination, purification, and water monitoring developed for the national water carrier created an industry that exports more than $2 billion in water technology annually, showing everyone that a determined nation can change its difficulties and completely transform them in a revolutionary way. This Israeli project is more than just an engineering feat. It is a testament to what can be achieved when technology and determination come together to overcome seemingly impossible challenges. Today, as the world faces growing challenges related to water scarcity, the national carrier stands as an example of how engineering can create sustainable solutions for complex problems. It is proof that with proper planning and advanced technology, even deserts can flourish. Thank you for watching this video until the end. And to you who became a member here at Construction Time and you who follow Construction Time, know that Construction Time gave you the opportunity to become a member here on our channel. In addition to several benefits such as ad-free videos, early access to videos, and exclusive videos, you also have a chance to win a personalized mug from here at Construction Time, and that's for as little as 15 rays. Just click the button below to become a member or scan the QR code that's showing on our screen using your cell phone camera. I'll wrap it up here. A big hug and see you in the next video.